Closer. Hello, Stephen.
Hello.
Hello, Lina. Hello. Hello. Hello, Boston. So probably I need to bring in the academic calendar so that we discuss timeline. Does this record looks like correct year and correct date? Right? It is what you.
Only this
Huh?
class. I have only this class.
Oh, your schedule is free. So I suggest, so today is 21st, right? Cool. Yes. So we do have 1, 2, 3 labs left. So the plan is as follows. Feedback comes from this. Okay, I see you connected.
Hello, Professor.
Hello. The suggestion is on the May 7th will be due date for written reports for the projects, and we'll select the day on the exam final week for presentations. So it will then you will be busy with other exams in one hand, which is not good, but what will be good that you can find a time when you are not busy with like regular schedule and you can dedicate like 2 hours instead of 1 for presentations. So the suggestion is that everyone invests time in doing projects and they will visit and talk, and they will give some announcements. So as you have noticed, the NERSC decided that they want to have a vacation today. Or not a relocation, they need to reboot the system. And it should come back from minute to minute, but we do not have actually to wait. So I'll show the safest people in the audience are Boston and Laura. And Steven, of course, because Boston practices last on CCAST, and Steven and Laura were practicing Gaussian on CCAST today, right? So I will show how to run last on CCAST with understanding that as soon as there's come back, it is worth of doing everything there. So it is CCAST is maybe like 100 times quicker than Photon, but 10 times slower than NERSC. And we all humans will have some limits of patience, and waiting until job is done is not always easy. So will show something quick when visit one-to-one, and I will start with winner because it is where we left off, right? Probably I visit those who are in the class first and then go to online. And I think by today, Sarah and Kay are in the best standing. So I think your projects you can complete projects without any help compared to other projects. But I'm not declining to contribute to help. Before we dive into practical things, if you do see at least a minimal probability that running heating and molecular dynamics can be beneficial for your project, consider to start it. Okay, I see your hand. Consider to start it today. So, of course, we can launch such jobs on CCAS, or one can wait until late night to be maybe from home when first will be available and just submit jobs. Each of you is a master of your own project. You decide what to do or not to do. I am only like a consultant. But the heating and molecular dynamics jobs takes more the longest time, and they are last candidates to be submitted in the few hours before the due date for report or for the report. So one needs to think ahead and plan, because often things do not work from the first time. You need to debug some errors, and it's better to plan on this most time-consuming work right away. If you're absolutely sure that for your project there is no benefit of doing molecular dynamics, you're fine. Although I can argue and explain that for any project it is beneficial, but just think about it. Okay, you please tell why you raised hand.
Professor, so when we need to submit a report for our project, which date you select?
Do you see the screen? Here?
Yes, 10, 11, 12, 13, 14.
So, the Friday when we have a last day of class, right?
Yes.
So it is the absolutely last due date for the reports.
Report.
So if you and I think on
And presentation? When we need to present?
On the exam, on the finals week, you select the day that is comfortable for everyone.
Oh, so it will be depend on me that I will choose any date from this, right?
No. We all will present at the same date.
Okay, same date. Okay, I understand.
Yes, because the philosophy of presenting, you're not presenting to me. You're presenting, you show that you do not fear unexpected questions from audience, and there will be likely visitors. Like I will invite your research advisors and students who took this course in previous years and instruct them to ask you tough questions. Tough questions, not like check your background knowledge, but explain the results that you're going to generate. Like how you connect objective measurements and critical thinking logics. So, and you may feel some irritation when I tell this word, but when you practice it, you all will enjoy it and you remember it as positive memories later on. Just believe me from previous years.
Okay, thank you, Professor.
So we'll either look what will be written as a suggested exam day for the class, or we will just make a democratic procedure and select the day that is comfortable for them. On Monday, not Monday, Tuesday, May 4th. So it's our last lecture before due date of the reports. I'll try to invest the whole lecture time into instructions, what to write into the report. So it doesn't mean that you do not need to do projects before that. So assuming that you have all data and you already have some draft, some of you are active practicing researchers who are authors of multiple publications. Some of you may have written just conference proceedings or reports in other classes, and you may have a little confused how to place large chunk of data into a limited number of pages. So spend the whole hour or whatever to all details how to arrange information. So if you feel that there could be some confusion, I'll try my best to resolve it. And on it is the Wednesday, let's assume that most of the data will be ready, but it will be like a backup. If something like today happens, then earlier then you can type loose ends or prepare some models for next week presentation, but plan on completing things this week and next week. Okay, so what is the plan? What you can do right now? Because if you do not centralize activity but more one-to-one visits, so I will start this project of Lumen and to show something that others can just borrow some ideas. So Austin probably cannot because he already knows how to practice last consequence, but I will do a demonstration. And by the time I visit you, please develop questions or prepare some like models that work or doesn't work. We discuss. We'll try to maybe spend 15 minutes per each, and then it will be equal share. If I spend more than 15 minutes with someone individually, let me know and interrupt me so that okay. Oh, microphone is not working well. You don't hear me?
No, not properly. It's
I think you should hear me. There is a feedback because I'm sitting near to the sound speaker and it creates this feedback. But just let me know if I need to repeat something, and then probably to camera is off. No, it is not off. It's on for sure. There are even two cameras.
Professor. Could you
Yes.
please means there is some problem with microphone.
So you don't hear me well?
Now it's clear, but before when I sent you message, it's the
No,
few
because I
words
was
I'm
hesitant.
not able to hear what you said the last things like it
No, I
was.
was hesitant and I was not speaking loudly. I think now you should hear me, right?
Yeah, now it's okay.
Okay.
Yeah, because you the microphone it you change the position of the microphone, right? You
Yes.
just hold it right this way.
Yes, yes. Correct.
That's why before it was maybe somewhere that's why I am not able to hear you properly. Okay.
So now 15 minutes for winner are starting, but I'll first prepare some visualization and then talk. Because otherwise it will be quite boring. I'll try to be real quick. Okay, so model for PPO model is visualizing disorder on the natural surface. The main observable is just binding energy. So you can do some additional side calculations, but main is binding energy. When first you compute simulation cell where this amino acid is adsorbed to the metal surface, then you take the water and chop, remove all metal ions, and compute total energy of.
Well, I can use the model that you sent, where they are bonding, right? Simply that's one.
Yep.
And calculating the bonding.
Yes.
And then I will repeat this value.
Well,
Just to.
there are several scenarios. One is try several binding geometries, binding modes. Right?
Yeah. So I
Try
have
to-
another file that
Yes.
has separate, so I can do each one.
Try to put them at a different angle. And then since time is limited,
Yeah.
another option is to take only one configuration with understanding that it is not complete work, but deeper into the mechanisms of binding. Maybe screen different oxidation states, different spin configuration, and see which one gives better binding. So focus more on the electronic part rather than spatial configuration. So what is shown here? Give anyone to solid state. Newer indices.
What?
Do newer indices. MILLER. Tell anything to you? If not, don't hesitate. It's okay.
Yeah, magnetic strand.
No. Miller.
Miller? Miller indices. I heard about them.
Okay. So the solid can be cut at different angles. Right now we are exposed the I think it is 111 surface, but one can cut metal by exposing different surface with different pattern of ions, depending on at which plane you cut. So it's also another degree of freedom what one can do. So the stuff which is shown here is total density, although you can do partial charge density with particles. And if one looks here, if there are regions of space where density is shared between molecule and surface, it is kind of indirect indication that there is some binding. Even before getting binding energy, you will see that it will bind. The calculations here are done with spin polarization. There is a subtraction of spin substance spin down. So even if the system totally is in the single state, if electrons are paired in total, in some regions of the molecule, they can take. There could be imbalance between spin substance and spin down, and one can analyze and derive some conclusions. If you see here, the carboxylic group is deprotonated, which as researcher of biopolymers, you may decide whether it is correct or not. And if it is not right, just add hydrogen inside. But hydrogen removed from the deprotonation here is placed like on this amine group and this amine group. So we may add or remove protons and add or remove charges to be more realistic. And those are only ideas because each calculation will take time and waste your time. So you should like make strategic plan how to work less, think more, and go immediately to description of results rather than collection data. So a little, it's not scientific but very technical thing. If LAB13 is used to show heterogeneous models, and I remember that class attendees from previous years missed this part. It's not about science, it's about visualization and use of the LAB. So if one takes the model itself and then it doesn't show lines between ions because bond tolerance is the same for all ions. And if one increases bond tolerance to show lines between metal ions, then it will create this ugly non-realistic ones between like hydrocarbons. The way to deal with it is to extract all lines in this metal into a separate file, and then bring in this file as on the top of this model, and then in this additional file one can set much higher bond tolerance, but it will affect only the group of atoms corresponding to salt. So it's just a way how to represent, because without it, it will be very uncomprehensive if atoms are not connected by lines. The side audience may not understand what you're talking about. So, what is the before we go to the command line? What is the possible reason for doing molecular dynamics if you decide to do it? Again, it's your decision, but molecular dynamics is one of the alternative ways, maybe a little too expensive, to measure binding energy, and it corresponds to experiment of thermal desorption. So if by heating system, this bioagent will desorb and fly away from the surface, it means this temperature exceeds binding energy. If instead of including temperature, it will just oscillate nearby, it means temperature is below binding energy. And by such experiment, like numerical experiment, one can illustrate mapping the body. Another benefit is that, for example, this two LAB carboxyl group with oxygens, if you heat it up, this will start molting instead of from one gold atom to another.
Could it break?
Break. It can depart from gold. The molecule itself will not break until very high temperatures.
Oh, okay. So it could be like just a very bit more.
Yeah, it can be dissolved.
Okay, so
Okay. So I'm returning back to different station just because the keyboard is a little better than the just quickly check if no, it didn't came. So everyone in the class is welcome to contact C-class administration and get accounts. I do not have power to set up accounts for you, and even the powerful Steven doesn't have.
I have an account.
Okay, but in addition, you need to connect license to your account.
What?
Connect license to
License.
use VASP VASP software. So in order, let me stop recording for a second, say something. Huh? So on the photo, I just recorded the way I log into CCast, right? So you put your username and then standard CCast in this view, right? And I will write something that is seen by the so especially when it is following type that so I'm connecting to the CCast. Then if you are using it for multiple times, you know how to navigate the reference and to the job queue. So here is one of the examples of the model, the one that we were drawing. So and if you please try to navigate with the directory. I'm not sure if I will have time to personally for WD. I can share it to everyone, but it will be a message for Lena primarily. I can, yeah, it's not a secret. But now you can. Yes, and there, for example, if you need to set, like, make a model with load only and rising only. So well, I probably need to paste it once again so that you get it, and otherwise you will not see what yeah, you probably may want to microphone. Otherwise you'll get this development feedback. Okay, so make directory load order. Copy everything there because it is quicker. And here I can, without going to XYZ, one always can convert VAST format into XYZ, modify it in LAB rather than convert from XYZ back to VAST, which is visual, but one can do quicker. So I do So the first 64 atoms are gold, and then after there are so many atoms which are this hydrocarbon. So the line number 10 is the first one with gold, and then I count 64 down. So 9 plus 64 will be 73. Escape column 73. This is the last gold atom, and you see the coordinates change from 7. And everything after will be non-gold. So I type D, some big number, count D, erase everything after that. Yes, then I erase this, erase this, erase this. And by now, it is a model with gold oil. So the pot car includes all elements, but we need only gold. So we can either recreate pot car or edit the existing one. Carbon was started in line 2030. End of data set. Now, from this record, PWPD, carbon, all other elements are started. So you can type D, then some big number, then D, and erase everything. So right now, it is the pot car for gold oil. The in car can be left whatever it was used for previous calculation. And sometimes using 0 ionic steps will not work for big systems and metals. It needs to go a couple of ionic steps as well because to reach convergence. And remember, when we were working on Bursk, there is a submit dot something script that we submit to the queue, right? If you are working on CCAS, you also have PDS scripts to submit, right? Yes. So it tells which job to run, like whole time, number of processors, and one can copy this thing if you are doing it in a different directory. Copy to the from here to this. This into copy chat. And to submit the queue, type. So on NERSC and CCAS, there are different queuing systems. And on NERSC, we are typing as batch, right? And on NERSC, we type queue sum, right? Submit the job, it gives the index of the job, and then one can check. if the job is developing healthy. If it does not, you will ask experts in use of CCAS in Boston, but now I think it started. It develops the outcar. But from my experience, I know that there is a little randomness, whether it goes to good or bad nodes. Maybe Steven knows some smart way, but I just make a copy of the same directory and run it once again and make setup competition between jobs. So hopefully the job is running, and for the minimalistic set of data, you need to wait for results of this world one-way system, and then you need to make the same operations to cut gold and keep one of the more, and also find the total energy. If the job will not progress further, because it should develop more steps, we will consult with Boston how to trick the CCAS if the jobs are not working. So you can ask directly him because he has more experience. So Boston, you can just look and maybe tell right now if you see any word of wisdom for selecting a good set of processors and CPUs to optimize it. Or you can think on the background and give him later. So
Maybe the comments on CCAS is similar to what?
no. The basic commands are similar, but
Yeah, I noticed.
but
two of them.
but interaction with the queuing system is different. So so here we are in the directory which shows this code and optimizer, and here the last step of optimization. Here the number -318 and 49.49 of output nodes. So this is one of the three most important numbers. So you need to record this number, then wait until the job is done in this directory and get the same type of number, and then make more to one way and also get this number, and then subtract this one combination which will give binding energy. It's like minimalistic set. Any quick questions?
No, so far I'm confused about changing.
So that we do not waste time to try to run it there. But as soon as nurse will come back, I recommend doing things with there. And maybe last thing, and I use a little bit more time on Linux case because there is some universality. If one needs to copy so suppose I want to copy everything that was done on CCAS to the photo, to the certain directory in Linux subdirectory. And just everything same as in mouse space, standard space. Then target directory. And then indeed transfer everything. Now you can access the data on the portal. And whether you do calculations on NARS or CCAST, you can store intermediate copies on the portal and download them through a suite of window by drag and drop. So I'll talk to others, and if you will be here, I visit you once before we complete the session. I see Sarah is very serious, looking on the screen. So, Sarah, do you have CCAST account?
Yes, yes, I
Okay.
have.
That's good. So I will visit Boston and Vola because they're in class, and then I will make everyone a co-host and visit those who are online. So this is just the service. That's it. And realize that that's kind of invites like often. So how do you see some question to the which you watch video? It's a probable question. I'm not going to answer it, so the video on the solution. Think about that. Let's go to the images. Yes. So this is it's Yes. Yes. Okay, are you online?
Yes.
So Ghost and Vampire is sitting on the left side of the room here. And can you please help us, try to help, if it is too hard, do not worry, but can you please verbalize your vision of connection between two concepts?
Sorry, Professor, you were talking with me?
Two concepts. Talk about connection between two concepts, the following two concepts: doping and injection of charge. Boston wants to learn more about it, and you can teach us. Okay, would you like to speak on this subject?
Yeah, sure. Professor, can you repeat the question again?
Yes, connection between doping and
Yeah.
injection of charge.
Uh, you asked me in a theoretical part, what I need to do.
No, simplest answer is yes. There is a connection.
Yes, there is a connection, of course, but
Okay. Yeah, thank you. We do right now. We do need more.
okay. You just simple question. I thought theoretical.
No, it's not complicated. Luna, you were raising hand. Were you planning to contribute to this?
I just wanted to say
Yep. Good.
Professor, I'm here. Let me know when I need to share my screen. I'm here.
Okay, yes, if you can not earlier than in about 20-25 minutes, I need to finish this book and talk to Wall, and then I'll go to those who are online. So, okay. So I'm doing this. You already covered the subject of this. Business, which is equivalent to something easy to practice. So this is not true. Practice the future expression process. So this handwritten is not finished. So so you can do this things on what you do. Try just not to the backup. Transfer it. This is how you use to come your sessions. This. Yeah. Let's try to read up on Zen. Makes sense. Which exam will be which subject? In which class? How more looking? Huh? So it is on the right? Let's open the meeting first. So, because prevented from doing others. false. So, the calendar has to shred the function due to the list values and what it equals. Okay, so which one is the Huh? Which one? The smallest one. Basically, some calculations to find surface and check this. Yeah, this is more important for this context. How should I play this? Finish this part. Potential. That's because so it's completely each problem is declared by Holy. And we will consider more problems that were missing layers. Yet we were assuming that cover here and connect to the approach. Here we don't do it. So yes, so working approach skills. Here we will not stay and the larger the number is better, but take too large number to work forever. Okay, converse, but the question is expired. So good. Yeah. So if you zero, so if you do no optimization, is to check if it works. One step, how much times can be changed. Work on the background. Mhm. Mhm. Alternative approach. It means besides being your overall must to select slightly different people that you have the first. But when you put your radio image, then you need to describe each capability for use because of the opportunities. Yes. Yes. Mhm. Um, mhm. Hmm. It's two numbers. Because you're only is to put the first K6, K7, you need first one and do that. So the board, the same like space, space, seven, space, space was happening for some other in some other line. Not very in the war. Correct. Mhm. So, yeah, you usually do raise it. But it's, but it is only 1/8. So you're 85% correct. So you see these numbers are put in. You can look. So as soon as you arrive to number 60 or maybe earlier, you are actually ready, you will be able to do this states and if you prefer to work with try to do just copy microphones and really for the sound of the quite this job can be done. per charge. So it's not a joke. It's shift 7 symbol, and then they should stay running. Yes, so, it says so send me emails that you will. It's two, and it's successful. We go to, we need to create localizing one. Yes. If you are willing to decoration. Yes. Finish this one.
Because I want.
Yes. Okay, you raised your hand.
Yes, Professor.
Yes, I'm here.
Because
Let's check if maybe nurse already came to our life. Not yet, unfortunately. Okay, so what's your question?
so, Professor.
They need to make everyone a co-host.
Oh. So, Professor, you already shared with me the model, but that one in the NARS, right? So
No,
now
there is a copy on Photon.
copy in Photon,
Yes.
but
I-
it's it seems like that the link you gave me, it's like that I need to transfer file from the NARS, isn't it?
Let's go into your directory and Photon and see what is there.
Okay, Professor, let me share my screen.
Yeah, you can share.
Yes.
Share screen.
Just what happened? What? This one. Let me go.
It looks like you are reading about glass transition.
Not
Right?
now, actually. When I was in the office in the morning, I read this paper because I need.
I know everyone in your research group is specialized and in polymers and coatings. It's like a popular subject.
What is that one? Scratch 7 this Kia project.
So let's check undoped.
Okay, just 1 minute. I need to. Oh shit! What happened? Oh.
Undoped.
This one or this?
Yeah, they are different only by the angle.
Yeah. Okay, let's copy this. Control C, and I need to remove this one. Seed.
So I think you are you have enough data to at least to do density of states, right?
Yes.
So you should do it right now without waiting for NERSC to come alive.
Yeah.
So do density of states for this model and for the one with doping.
Should I do it now? Do I?
Yeah. Oh yes.
Okay.
And you can also, after you do those, you may try to do absorption spectra.
Should I copy this one because I want.
No. You can if you want you can copy, but again, you are the owner and master of your project and your files. Do whatever you find it necessary with them. If you think you can copy, if you want, you can do things in the same directory.
Yeah, Professor. So I want to do it after breaking file because I'm too much tired.
Doing after what? Oh yeah, yes. But plan on completing
and then I will.
simple things first.
Okay, just plot it right now.
Right.
Yes. So, do I need to change Inker file here or nothing?
For which purpose?
Oh, now I'm not doing anything like not anion or cation, so I don't need.
You can do it. It will be reasonable, especially for undoped model. But you can strategically manage your effort for making density of states out of these calculations. You have out car files. Wait. What do you do? No. Do not do it. Why do you do it?
Okay.
Take a piece of paper and write a plan. So look, if you have outcar file here with the energies,
Just 1
if it
minute,
is
1 minute, 1
if it
minute.
is if it is already there, then you do not need to rerun VAST. So you can process your data
Mm-hmm.
without running VAST, even if the core is not working right now.
Yes, there is outcar file.
Okay. So look if check if you can extract list of orbitals from the outcar file. And if it is not, because orbitals were done, let's check, let's do more space outcar. Just arrow up
Yes.
and push tabular.
Tab.
Tab to the left from Q.
Yes. I
Okay,
did.
yeah, there is no other outcar. Let's go to CD space, erase this more outcar.
Mm-hmm.
Space.
CD
CD space dot slash undocked uppercase. Uppercase.
Okay.
All uppercase. All uppercase.
All uppercase. DOPED. Oh. Missing. UNDOPED. Undocked.
Enter.
Enter.
LS.
LS minus LT.
So let's look. Can you scroll and show what is at the top of this?
Okay.
Scroll. Okay, stop.
Yes.
So there is an outcar number 19. Let's do more space outcar 19.
Okay. More space outcar 19.
Outcar 19. No, without outcar and then 19 as a file name. Yes.
Yes.
Enter.
Enter.
So you see some orbital energies, right?
Yes, there are lots of things inside.
And probably you should take those from the very end of the file.
Yeah.
And use them to plot density of states.
It seems like that it's too big.
So explore. Can you pass me control over this terminal?
Of course. Let me give you the permission. Just 1 minute. Remote. Now you can control.
Okay, thank you.
Yeah. Oh, you can control. Yes, you can control that one. Green.
Well, let's check how many orbitals.
Yes.
768. Red minus A 7. You're looking for Fermi. Can you? Yeah, thank you.
It's just nothing.
Outcar 19, and we can direct it into the states. Maybe.
Yeah, it's done. Okay. Oh,
So you can try to build density of states out of this file.
okay.
And you do not need anything, any vast calculations, right?
Yes, just that. What?
Wait. What are you going to do? Just tell me.
I want to plot density of state.
But you haven't created the DOS Fermi file.
Oh, okay, I need to.
And I'm very interested in your progress and in your project, but I will not be able to follow step by step. So after we agree what you do, you continue it on your own, and then
Okay,
later.
I will do that. Let me because let me eat something. Then after that, I will finish this one for that dop and undop.
Yeah.
Actually, I will do this one and I will share with you that what happened with this figure result. I will share with you. Yes.
Okay. Yeah. Sounds good.
And Professor, let me do the top one. Yes. So later I can do work here. So I need to.
And code opt number 5. Code opt 5.
This one, right?
Or without rotation. Code opt 5.
This.
Yeah.
Oh, so
and here you also should do. You should take the latest outcar and generate density of states out of it.
okay. So what's the latest outcome? Just let me check. Okay, latest outcome is 9. Outcome 9.
Just scroll through. Maybe there will be more of them.
Oh no, there are more. 10, 11, 12.
But you'll be able to find. Just find the latest one.
Yes. I
If
think
you have
outcome
it.
12. Yeah.
Maybe this latest
Yeah.
stage optimization.
It's latest because others are maybe did it before. Outcome 12. This. Right? Okay. So I will plot these two and Professor.
And your next step will be to compute absorption spectrum, right?
Yes, yes.
Any other questions?
Yeah, Professor. I will send you email and
Yes, please.
I
Yes,
need to
sure.
talk with you later because it's
Yes, please.
okay.
Okay. If there are no more questions, yeah, thank you for stop sharing. Okay, is it your new hand or it's just from the previous discussion?
Previous discussion.
Okay, yeah, thank you.
Professor, I need to leave because
yeah, you can leave and log in later.
yes,
I
yes.
will stay here a little longer than scheduled.
Because a fasting break. I need to break fast around 8:27.
Yeah, come anytime you want.
Okay.
And send me an email if I'm not right.
Yeah, and thank you, Professor. Sure. Bye.
Okay. So I'll probably talk first to Sarah, but Stephen, please plan what you will be sharing when we talk after Sarah. Either show if you have some calculations or show some browser with attempt to find the structures online. Is it a good plan?
Yes, I have a structure I found online that I'd like to talk with you about.
Okay, yep. I'll talk to Sarah first, and then we'll go and chat with you. So, Sarah, would you like to share screen?
Okay.
Yes, sure. Yeah. I haven't started doing the project. I have some other stuff to do. This week I was busy, so I have planned to start the project on the weekend. However, you said that the NERSC is not available and it's out of service. For how long it is out of service?
It should come back about now. They're telling like either 6 or 7 p.m. Pacific time, which will be either 8 or 9 hour time.
Okay, so it's just for one day.
Oh yes, yes, and they do it about once per 2 months because it's quite a big facility. They need to do reboots.
Yeah, I see. So
Yes, keep talking, please.
sorry. So for doing our project, we should use NERSC. It is not possible to use Photon.
You can try, and even if we all know that Stephen is generous and gentle to us and will not persecute, you just he's smiling, showing that maybe not. Even if Stephen personally will not persecute us, the photon is not as powerful. So the systems that we are trying to describe, like the meta-organic complex that Lola is looking at with 50 atoms, it is okay.
Yeah.
But 100 atoms with is already too much for a photon.
Yeah.
And you can try doing it, but it will expire your human patience. So you will start and you will see that the job progressing like 1 electronic iteration per hour, and you need to do 60 for 1 convergence, and then like 100 times 60 for some minimalistic molecular dynamics. So it will take a month on photon, while it can take like 30 minutes on NERSC. So it's just different orders of magnitude and productivity.
Yeah. Yes.
You can do it on a CCAST, as I was showing for Wina.
Yeah.
If you have some emergent, if you have ideas that you want to do calculations right now, it's a good plan. You can do it right away, and I can show how to do it on CCAST. But maybe let's. What you can do, you can set up plan and even set up directories and in-cars on the photon, and then later on you can copy the whole set of directories either to CCAST or NERSC and start jobs. But thinking and strategic planning is more important. So yes. You can, if you don't mind, please tell me more about your project.
Yeah, for using CCAST, shouldn't we have access to VASP? I think.
Yes, but I'm going to stop to pause. Okay. Yeah, please keep talking about your project.
Yeah, another question that I have, if you see, for example, here, we have a lot of outcar file number 1 to 12, something like this. Why we have a lot of outcar file?
Okay.
Before we had just one outcar file.
When you will be presenting your results in public, never tell about them. I was trying to play on your side, and do not tell anyone that someone gave you these files. Tell that you created them yourself. But the idea is the following. Systems like the one you are practicing, the Wina is practicing, Kea are practicing, have a lot of morphological uncertainty. So there are several local minima, and in order to find good optimized structure, one needs to optimize it for a long time. So what I was trying, how I was trying to help your project is to optimize it for maybe like 30 steps or with until certain limit. Then copy concar into postcar and run optimization once again. Then copy concar into postcar and run optimization once again, and so and about 20 times with different settings to approach closer and closer to the global minimum. If you do calculations for like as your profession for bread and butter, you will do it yourself. But now for training, you probably should go immediately to more interesting part rather than this. It's like in the wet lab, you do purification and cleaning test tubes. Someone needs to do dirty work. So look for the latest one, the outcar, and at each stage, the outcar was saved because who knows, maybe optimization with wrong parameter will break the system on pieces or go in the not deconstructive way, so that at each step I can return back and start where I stopped. Yeah. But it seems that everything went successful, and if you need to like do density of states, same as K was instructed, take the outcar with the latest number, like outcar whatever 14 or whatever you have.
Okay, thank
you. Can you scroll through this directory and find the file that is named movie all.xyz? Movie all, or you just type ls minus ls movie star, just put, no, don't put dot, put star.
Enter.
Steven is typing BRB. I don't know what does it mean. Huh?
Be right back.
Oh, okay. Oh, I'm learning something every day. So do you see? Yes, it's in the last column, right?
Yeah.
So if you download this movie files into your local computer and either on Photon or on your local computer, you can try. Oh, local. Sorry, I have clear mind but not clear way to put words into sentences. Download movie all on your local computer and open it with VMD. And if anyone needs to go, it's okay. The plan includes only one-to-one talking. Yes? Sarah, while you are downloading and opening VMD, I have a quick question for more.
Sure.
What color will not change? It will absolutely the same. You can safely copy. You can also copy postcard before you do optimization. You can copy postcards. It's fine. Font card will be different, but postcard is the same for all the calculations. No. You're doing right thing. No. It's the main idea. So. It will, but it's running even if you close computer and depart it. You see, was one copy of was floating in one. You can. I think that it will continue. Oh, if it will not work, you will just bring. But you can, if you fear to close computer to write something, you can go to the web, but not necessarily go to the web, open desktop, and just keep jobs running there. Right? Yeah, that's good. But if you do this Shift-7 ampersand, by idea it should keep working even if you close the computer. Yeah, that's okay. I hope very much. If it does not, let me know. We'll find some solution. So, Sarah, would you please bring the front panel, the control panel to the front? This one, and click the triangle thing. In this panel, yes. So it just shows this several steps of optimization. So how it was changing and optimizing, right?
Yeah, it is.
So yes.
Boundary. Yes, here. Is passing the boundary.
To avoid this strange lines across the boundary, you can stop movie for a second. Yeah. Now go to representations. And replace CPK with dynamic bonds. Yes, then dynamic bonds. Okay, and create rep, because dynamic bonds will show only the bonds. And now select van der Waals. Drawing method, VDW, click. And now sphere scale, do it smaller. Okay, and now click. Now go back to dynamic bonds in the top panel. Yeah, click. And increase the distance cutoff. Okay, yep, no, too much. Otherwise, yeah, about this. And now, if you run the movie, if you click go to the center of here, so it will not do the strange lines across the boundary. So dynamically updates bonds just based on the interdynamic distance. So if you run later on, if you decide to run molecular dynamics, such visualization will be very interesting. Now it is only a sanity check if you have reasonable geometry and nothing was broken.
Okay. So are you suggesting to run molecular dynamics also as well?
Yes. If you were listening our discussion with Lina, so molecular dynamics is not a top goal for this adsorption project, but it is a helpful tool. So if you run dynamics, for example, at 1000 Kelvin, and molecule is desorbing, starts to float away from surface. It means the absorption energy was smaller than 1000 Kelvin. If it still stays connected, it means they're balanced. And it is standard experiment called thermal desorption that is done in labs to measure binding energies. So you can mimic it. So tell me more about your plan, how you see your project to be completed, what you want to find and how you want to achieve your goals.
First, as you suggested before, I should calculate the binding energy for each cases.
Yes.
Different amino acids. And
well, at least for this one amino acid, let's be not very ambitious. In the remaining 2 weeks, or this meeting is done, basically during we have only one Wednesday left for new results. So it's as we cannot have very ambitious plans. Let's just start with getting binding energy for this amino acid only. Later on, after the class, if you and your advisor decide that it is worth pursuing, you can explore other amino acids and be more systematic. Right now, let's just do proof of concept, maybe with one, because you are busy with other classes, as you've told, and there are not much time left. So binding energy, how would you do binding energy here?
As you suggested, I should run 3 systems, one including all the 3 components, water, amino acids, and the clay. The other one, I should just consider the amino acid, and the other system, as you suggested, I should just consider the water and clay, yes? And then
yes.
I should distract these 2 binding energy, and this is the binding, the energy of the system for these 2 models, and this is the subtraction of these 2 energy will give me the binding energy of this model.
That's correct. That's correct. Do you know how to break the system on how to remove amino acid and keep only clay, or how to remove clay and keep only amino acid?
I haven't tried it yet, but as you suggested before, I should utilize Jmol and just manually delete the atoms. Yeah,
but please start doing it if you have time, even right now, because you do not need NERSC to delete atoms with Jmol, right? And there is a little percent of human error. Like if you click in the wrong spot, we need to have some time to correct errors.
Yeah.
Do not leave it for last minute. So if you have energy and time, try to do it maybe right now, today, because clicking is not very complicated. You can try clicking right away, and then you prepare a directory with clay and water and with amino acid only, and later on you will submit jobs. Yes, that's a good plan, and it will be the result number 1. It will be like a little boring, but practically important. It's something that can be compared with experiment for your chemistry of cyborgs, right?
Okay.
So what else do you see? So binding energy, maybe molecular dynamics. What else do you see? What you want to try? Which numerical experiments you want to apply to the system?
I just checked some papers and see they calculate also the charges, molecular charges for the system. Maybe we can do it also. I'm not sure.
Yes, it can be done, and it is interesting, but for molecular charges, it's better done in Gaussian, but Gaussian will not work for periodic systems. So I'm not against it, but it's not the easiest and quickest thing. Instead, what you can do is just to look on the total charge density. So will you please download the CHG file to the same directory and open it in VMD?
Which file? Sorry.
CHG.
CHG. This one?
Yeah, with uppercase. Do LS and then CHG with uppercase.
Okay. Should I open it in VMD as well?
Yes, yes.
So I should close this.
No, keep it here. Do not close.
Just
Open it on the, yes, open it on the top. Select file type.
The type is
File type. Click and scroll to the WASP charge car. The first thing is WASP. Yeah, WASP charge car. Yeah, this one. Click. Click. And now let's go to representations. Yeah, you can rotate it. So let's go to representations and make this image a little bit more beautiful. So instead of points in the bottom, you have points, replace points to solid surface. Now material from opaque create to go to transparent. If you slowly move mouse, I will navigate where it is. Slowly to the right and slowly to the up. Up. Slowly
This one?
more up. More up. More up. More. Yeah, here. Click. Transparent. Okay. And now you can pull this little bar from left to the right that you were trying to do. Yes. Just try to pull it. Let's see what happens. So, and for better visual effect, make sure that you are at the latest stage of your movie. If you click, yeah, VMD main, make sure that, yeah, okay.
It is in the last frame, I think.
Yep. It looks like there is a little offset between the positions of atoms and charge density, but basically this is total charge, and it's my fault that I didn't instruct the whole class about it. So this clouds that you are showing right now is the rho, is the charge density about which all theorems were proved. So distribution of electrons in the system. And it is a main quantity that is computed and saved by WASP. So can you please increase by view on a mouse so that we focus only the area, the interface between molecule and the clay?
Here, I should increase it.
Yeah, increase it like 2-3 times. No, not the charge density. The whole image. Click on the panel with the image and just enlarge it, make it bigger. Yes, even bigger. Enough. So now let's go back to the density in representations. Represent, yes, and select smaller ISO value so that clouds will be bigger. Bigger. Yeah, enough. Now let's look on this image. So you see there is a hydrogen bond between. Move your mouse up. Slowly. No, just move your mouse. Slowly move your mouse. I want to point your attention in a specific place. I can show it over here. This area where oxygen from the surface interfaces with hydrogen from the amino acid, right? So here you see non-zero density in this area between molecule and the surface, right?
Yeah.
So if there is a charge hybridization in the space between molecule and surface, it likely indicates that it is a chemical bond or very strong physisorption. So this analysis of charge density prompts that it is the binding energy will be noticeable, will be quite large.
Yeah.
Okay, now let's open, let's go to main panel and open the charge file once again. File open, like open, do not erase anything, like file open, new molecule, and select browse, select this CHG file once again. Yeah, let's charge curve and wait. Select charge density, spin up, minus down. Second option, yes. And now click load. And let's go to representations. Representations.
Oh. Okay.
And select the replace points to solid surface and opaque to transparent, and then coloring method to the left. Just slowly move mouse to the left and up, left and more left and more up. Next up.
This one?
No. Next panel up. Move slowly up. Yes. Click. Select color ID. Yes. And select color like maybe red. Okay. And now pull the panel that changes the value of either surface. Yep. Try to pull it in different directions.
Doesn't work. I'm trying to put it right,
Okay.
but it doesn't work. Maybe we can insert something here. No?
Okay. Maybe in this configuration it has no spin density, no difference, but it is a little suspicious because there is an ion in the center, and typically it contributes spin density. So I would suggest you do standard things like density of states, absorption spectrum, in addition to your binding energy. And then, if you have energy and time, you may try to do another calculation with different spin up, spin down, spin up, down value to change spin polarization and different charge. Okay. Does it look like a plan?
Yes, I will do as you suggested.
Okay, yeah. And even if you are tired and busy and do not want to do calculations right now, you may take a piece of paper and write a plan, which calculations in which sequence you want to do. It will not take much of your time, but you should invest maybe like at least 3 hours for the project. Not continuously 3 hours at once, but maybe 6 days, half an hour each, something like that. And make plan which jobs you want to do and which operations, like creating cell, plotting densities or density of states, and then save materials in in the Word file as a template for future report.
Oh, okay. Awesome. Thank you.
Okay, if there are no more questions, let's stop sharing.
Sure.
And Stephen, now all my time is yours. Please share screen.
Okay. So you can see my screen now?
Uh-huh.
Yes, and so
Can you rotate it? Can you rotate this model?
yes,
Uh-huh. Does it tell the keyword alpha? So is it alpha ruthenium chloride?
I'm not certain.
But it looks very much like this is it.
Yeah. So I was thinking is that since this is already a rhombus
Mhm.
now, I
Mhm.
could just sort of clip it around here and then
Mhm.
atoms, and then I would have the diagonal cell that we were looking for.
Mhm. Yes, this is a really great plan. Did you download this to your facility?
Not yet. I was hoping. Well, I found it yesterday, and I was hoping to talk with you to make sure that it'd be a good fit before downloading it. And if you say yes, then I will download it and get started.
Yes, yes, please do. And do you have tools to convert CIF files into VASP?
That I do not. So I can keep looking for a VASP file, or I can try and find a tool.
It's better to find a tool. And please download it anyway. You see a little head of a robot,
Yes.
and it tells on the right from it, it tells CIF. If you click, and you can, yeah, just download all of them, and then later on you analyze them. But computed is the best probably.
So, well, NERSC is down right now, but they have a VASP graphene. I know that.
Uh-huh.
And so
I suggest, I know that you have strategic plan for a bigger project, but maybe let's do slowly but surely and start from without graphene, just simple ruthenium chloride as a reference point, and then later on add graphene if time allows. But now it is an objective task and challenge to convert it into VASP. So we can look together for the tools. Like if you would please transfer this file to Photon. And maybe you're welcome to do it in your own directory, but just for quick checks, maybe you transfer, yes. Okay. Now let's go to command line and try to analyze this file from the command line. So it's
It's
001. I think it is scratch 001.
yes, 001.
Okay. Maybe you put it into research data instead of project, or you can copy it like.
Oh yes, I put it into research data. Nothing else in there, so I'll just go there.
Okay, so let's type tilde slash VTS, lowercase VTS, and then hit tab for continuation. Yeah, and now try to type CIF. Yes, and then name of the file. Enter. And do ls and check what happens. And now let's look inside this ruthenium chloride. Yeah, enter. It looks like a good candidate to be a LAST file. So we do not have a science which are ruthenium and chlorines.
Yeah.
But I think it is much better place to start rather than converting it, because it's already curvilinear lattice. So let's think. The Z projection of ruthenium atoms should be right in the center, like 5.5.
Would this be?
Yes, correct. So this 0.5 and 0.5 are two ruthenium in the middle layer, right? You have 3 layers.
Yes.
And the lines that have 0.5 in the Z projection are 2 ruthenium atoms that we need to keep. So let's check what are coordinates of other ruthenium atoms, and then we can probably safely remove them. Others are 0.16 and 0.83. Let's go back to the 0.16, 0.83. Okay. So first 6 atoms are ruthenium. Last 6 atoms, last 18 atoms are chlorines. So maybe let's exit from this from the VI. Escape from WQ. Escape from. And do CP, copy this file into postcar. Just copy name of this file, space, postcar. And now let's do VI of the VI postcard. Enter. So I do again. You can do whatever you like. I'm only providing suggestions, but I'm thinking in two directions. First, how can we convert it into a standard form? Oh no. You see the very top line. It shows ruthenium 0, ruthenium 1, ruthenium 3. Very good, very good. Perfect. Then we can erase top line and write ruthenium space chloride, because there are only two types of atoms, like ruthenium and chloride.
So this whole line?
Erase everything, erase backspace everything. Ruthenium space Cl. Now let's go to the line that filled with symbols 111111111. Make first, erase everything. Just do it. And now type 6 space 18. And save, escape, save and exit. Okay. So, and just in case, we can copy this CP postcard space postcard 3 layers. Just give some unique name, and it will be our backup file if we break something in the next day. Postcard underscore 3 layers. Name it as you want. Yep, good enough. Okay, so even if you screw up something, you have a backup. Now let's do VI postcard once again. So let's erase. Let's go to coordinates after the word direct. Yeah, delete first line, just DD. Type DD, escape DD. It will erase the whole line. No, escape without insert. And now type DD. Yeah. Now let's go. No. Exit everything. Escape Q. Escape Q exclamation sign. Enter. Once again. So delete first line. Now go to the next line and delete it. DD. And now keep this one. Yeah. How many lines did you erase? Stop. Now let's count how many lines you erased and how many lines we have left. I'm counting from the backwards. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. I think you are lucky. You left exactly 18 chlorines. Now let's go a few lines up and replace number 6 to number 2. Where number 6 to number 2. Just delete 6 and put 2. And now let's escape WQ. We are not done, but we need to save intermediate. And now let's do CP postcard, I don't know, intermediate or we have only 2 rutheniums, but 18 chlorines. Like ruthenium 2, chlorine 18. Or intermediate is fine. Enter. Now let's do VI postcard once again. And for comparison, let's look on the website where you took this model. So I believe there will be total 6 layers of chlorines. So for originally for each layer of ruthenium, there are 2 layers of chlorines, one above and one below. So if you look on Z coordinate on chlorines, we will see six groups. Let's check for the
can't make it bigger, but yeah, there's 8888, 8887,
uh-huh.
8695.
Steven, this is X and Y, A and B. Let's look on the projections on C axis, which is same as Z. And yeah, look here. So there are 3 chlorines with 0.9, 0.09. Then it's probably there are 3 with 0.23. Then there are 3 with 0.43. So they are in groups of 3, right? So there are 6 groups of 3 elements in each. Correct?
Yeah. Yes.
So we need to remove first 2 groups of 3 and last 2 groups of 3. So we need to erase this with 0.09 and with 0.23. Then keep the one with, can you scroll? Slowly scroll. Keep the 3 with 0.43 and keep with 0.56. And then anything left after we should erase as well.
Delete 0.76 and 0.9.
Yes.
Just marking down which coordinates those are.
So let's go to line number 3. So in Z axis it is 0.76. We can type DD. For now in Z coordinate we have 0.9. We can type DD. DD once again. Now we can skip next. Oh, no, escape Q. The one with 0.4 was a good one. Enter. Once again. So delete this one. DD. Delete this one. And delete next one and then stop. Maybe escape, save this one in intermediate just in case we erase something by error. Just escape W Q. Enter. And now, yeah, copy maybe intermediate to Oscar I2 or II, whatever. Yeah, okay. Now let's open the Oscar once again. So let's go to the one where Z projection is equal 0.09, and we can type DD. Now the one with 0.23, we can also type DD. The one with 0.76, we can type DD. For 0.90, we can type DD. And now the next 2 are good. We can, the next 3 are good. We can skip them. Go down, go next line, next line, next line. And then stop at the line where Z projection is equals 0.23.
Yes.
So this line can be deleted. Okay, now let's go skip. Next one is good. And let's skip and go to the next one, which is where Z projection is 0.23. And delete it. And then the remaining 3 can, yeah. And then escape WQ. Whew. Very good. Very good. Photon is not suited for massive calculations, but for this system of 2 + 6 of 8 atoms, maybe we can run single point on photon just for curiosity. So let's bring in, or let's create the pod car and then bring in standard K points and in car. So let's create pod car by CAT. No, not seed, but cat. Cat like concatenate. No. Yes, CAT space space tilde slash wavy line slash POT lowercase and now hit tabular for now type POT just hit tabular once again slash RU upper R lowercase u hit tabular. There could be more than one ruthenium. Hit tabular. Okay, let's keep the standard slash pod car uppercase pod car bigger caret. No, not the power, but bigger than the shift period. Bigger. No, not lesser, bigger. Yes. Space and type the word pod car uppercase once again. Enter. Hit arrow up. And use arrow left several times and replace ruthenium with chlorine. Delete ruthenium and type Cl. Enter. Okay, now you have pod car. And let's copy template K points and pod car.
Okay, get out of there.
Huh?
My cat is trying to climb up the back of my monitor.
Oh, yeah. My cat typically lays on the keyboard or just walks on the keyboard.
She does that too. Okay. Will you be happy if I set you up here? Yes. Okay, you were saying?
Copy here the templates of the IMCAR and K points. CP space tilde bin slash uppercase IMCAR dash and hit tab for continuation. Yeah, period. Slash in car is uppercase. Enter. And now CP space tilde slash bin slash K points. K space period. Enter. And now let's just look inside the IMCAR file so that it does only one, no optimization steps, so that we finish quick. So NSW equals 0. It's fine. So let's escape and save. Oh no, let's add the I spin equals 2. Without I spin equals 2, it may give like after precision law, somewhere here, type I, insert new line, or at the beginning or at the end, insert new line and type by hand uppercase I spin equals 2. if you modify something that you didn't want, you can, yeah. If you type insert and hit enter, it will create a new line. Just hit enter. Okay, and type I spin equals 2. Okay, escape WQ. No, escape. Yes. Enter. And now let's try running it. /bin wasp photon. VASP minus PH, and then hit tab for continuation. Enter. Very interesting. Very interesting. Let me log in and check what happens. Oh, by the way, Corey is back.
Hey.
So, but let me go to the what's the name of the project? I can do this. I'm not research data, right?
Yes.
Oh, I spin should be uppercase. Maybe it's not so important, but triple product of basis vector. I never had this error. It's very interesting. So since nurse, well, if you are busy and need to go to your home duties, it's fine. But I'm very curious. Let me share screen, if you allow me. I'm going to maybe use yeah. Thank you. Let me share the screen and do this little exploration on. So. Make directory. What? It did create on photo. It looks like. Where did it? Oh, okay. It was empty files. I was so surprised that it has wave car and all things. So it did create them, but didn't populate. More hardcore. So copy to the debug message here. Message. It is okay. Well, let's do standard instead of gamma. And just as a precaution, let's do this batch debug. Maybe it is an error here as well. Product of the basis vectors. It's the same error. Well, I think we shouldn't hold each other on the work, but let's meditate and try to solve it. But what can be the problem? What should be? So, oh, okay, maybe it is a quick fix. Yes, I think there is a chance that we will still resolve. It's listed 18 and in fact it is 16. And maybe it will work even on photon. I postcard. Yeah, I wasn't attentive. 6, escape WQ. No, it's still. It's still complaining. So what I will try, or possible ways to resolve is first compare the postcard file that we created. Yes.
From NERSC VAST notes, it says that triple product of basis vectors is negative, is an error that arises from improper chirality.
From improper what?
Chirality. We need to mirror the cell. VASP only works with right-hand systems, and it has a left-hand basis.
Oh, okay. So which means we need to which means we need to replace one of the minuses to pluses, something like that.
Yes, I think so.
Okay. Yeah, it sounds reasonable.
I will paste the note into chat.
Yeah, thank you. And also, I was so confident giving suggestions that we need to cut elements based on the last column, but it looks like the longest column is number 2, so we should base our consideration on column 2 rather than 3.
I can look through that myself.
Yep.
Professor,
Uh-huh.
After finishing the Steven's work, can I ask a question?
Oh, sure, absolutely. I thought you have disconnected, but thank you for staying so late.
No, I'm here. I'm
So
trying.
Steven, are we done? So
I think so.
let's try to meditate in silence and communicate next day and see what we discover. But it should be like a question of one sign in this 3x3 matrix. We'll fix it, and after that your project will be quite easy. It will be just basic runs. So the creation of the cell is the hardest part. Thank you for finding it, and I'm very happy with this progress. Thank you.
See you later, Professor.
Yeah, see you soon. Yes, Sarah.
Well, I wanna share a screen, but because you
If you want, you can share. I can stop sharing my screen. You can share once again.
Yeah, sure. Thank you. I am trying. At first I copy the movie XYZ and around 110 lines of the movie XYZ into the another file test.xyz to I just want to clean the, for example, the rest of the model and just keep the amino acid. And when I want to open it in the JMOL, I am using this command, but it doesn't work. The JMOL opens, but nothing. It doesn't let me to do anything. It just
okay. Let's open the test.xyz file. You can just stop Control C to stop it. Let's inspect the test.vi space. Or you can do more space test.xyz test. Yeah. Okay, starts 108. Scroll, just put tab space. Can you type wc space test.xyz? Enter. 110. And which number is at the beginning?
I mean, at the beginning of the file.
Yeah, 108.
Yes.
Yeah, it looks all reasonable. So I do see 3 types of quick fix. First, download and open it on Avogadro. Before doing, just let's think together. So first, download and open in Avogadro. Second, use Babel to convert to PDB and then open in JMOL once again. PDB is more universal. And third, if you download the latest version of JMOL to your local computer, it will be like JMOL 13 or JMOL 14. Latest version of JMOL is able to open postcar or contcar right away without any transformations. So try to do it and let me know if it works or doesn't work. And if it doesn't work, I'll try to do it myself from home.
Oh, okay. Okay, thank you very much.
Yep. And the fourth way, which I do not recommend, but just if nothing else works, we can arrange all atoms in the model according to their Z projection by sorting, and then cut all atoms that have Z projection bigger than certain value or higher than certain value, even without drawing the model. So it's only the like plan C, backup plan if nothing else is working.
Okay, let me try the ways that you suggested.
Okay.
It works now. Thank you so much.
Yeah, thank you.
The class is done. Finished?
Oh, yes, class is done long time ago. It was like consultation.
Thank you so much. Have a good night.
Thank you, you too.
Goodbye.
Boston,
I think I remember class you did 2 extra electrons, 2 electrons. Is there a reason you did 2, not 1?
keep closed shell configuration. If we do a practice I spin equals 2, then having odd number of electrons is odd. So if we remove only 1 electron, it is against this closed shell consideration. Then we need to go to I spin equals 2 and have separate orbitals for up and down. Another thing which could be very applicable to this model, I just don't want to overload these challenges. But since different is quite heavy element, there are electrons with large very angular momentum, and the spin orbit coupling, the orbital motion spin and spin frequency are non-negligible. Once the orbit coupling is non-negligible, so we use spin 1, spin 2, and here it will be not 3. But there is a progression. There is a so-called NCL, which means that those orbitals are combined in this way. So since total number of orbitals here is 4, here it will be also 4, but they will be filled by spins that not necessarily parallel to the axis. So it will be spinners with any possible spin orientation. And for heavy elements with non-negligible angular spin orbit coupling, this is it's a little bit more heavy and computational, and maybe it has higher potential error, but it's more correct way to. And this model for if we still write are more applicable. So if you have ambitions and plans to convert your calculation that you just started into competitive paper at some point, then one would work. Right now, just because of time constraint, just do whatever we do in class. And then later for promoting it to a level of competitive paper, or we need to do everything in this non-preliminary speed. And then for price and benefits are incompatible. For this high price, the second plan will be much more expensive. For this price, you will get at least a little small benefit. Instead of ionizing and removing 2 electrons, you can safely add or remove 1 electron.
And secondly, for the number of electrons, that's just simply taking the periodic value times that by the number of electrons. Adding them all up.
You are planning very correct and reasonable way, but there is a shortcut.
Okay.
If you do neutral system, of course, you're probably planning to hunt with closed eyes, is go to the forest and use machine gun, right, to submit like 100 jobs and then later analyze them. But maybe you submit at least 1 job first, like neutral, without any And then after this reference for job, task, we will, again, it's not a big benefit if you have high IQ and lots of time, you can look into periodic table, count number of items. It's a middle school problem. But when you find lazy and do everything else, task does solve this simple IQ problem. It counts how many items exist. And after first run, if you have healthy outcome, you get to take graph, number of electrons, space, outcome. And it will give you like number of electrons equals like 762 or whatever is in your system. And then you use this as a reference point, put it in the current, then add or subtract additional reference.
Okay.
Why this is better? Because pseudo potentials in the profile, they have some additional approximations that I was not pointing attention in the class. But if you look inside this work file, for example, carbon, how many electrons carbon has based on periodic table?
I don't remember which number of carbon is. My periodic table is so bad.
Mine too, but like H, nothing. Q, lithium, boron, carbon, nitrogen, oxygen, right? It's my periodic table.
So
Others,
6.
yes. And if you look in the plot card, if you write PAW 4.00 for carbon, so it uses 4 electrons instead of 6.
Okay.
Why?
Those are the ones not original.
Yes. And they do not contribute to chemistry or physics of all elements. And why waste time on computing through things? And it does this trick even with carbon and with heavy atoms it doesn't work. So it takes only balance shell and therefore it is because of this cheesy tricks it is quicker than those.
Okay. Because yeah, I was thinking of just running the neutral anion and cation all.
No, it skips like if there are like 6d electrons, 6 1s, 2s, 3s. Remove them from explicit consideration will effective potential that approximate there.
I'll just wait on those ones that the neutral is down. And then I have another question too. So I tried running that relaxation before on NERSC, like I said, the K is 256 cores. I specify like, but I set up for a wall time of 12 hours with that wall time, so but I wanted to make sure that I'm not making it unnecessarily long, because all of my calculations that I've done, everything important, not just this.
Oh, by the way, here in current SOC is for the one that I was telling.
Oh, okay.
Speak SOC for spinal.
So I was just wondering if I am doing anything in my car to make it run a lot longer than otherwise.
This NSW, if you put it by 50, it will bring you to the end of the optimization, but it will finish naturally, and then you will start. So when it finishes abnormally to the whole time, then it doesn't save way apart. It's more than computer power to the studio. If you do one was when the cards saved at the end of the partial optimization of our dynamics and we plan to restart, then it saves at least one index step because it doesn't start from random bits. It takes basically coordinates from previous world that it gives speed up. This hundreds and thousands of words and units of hours. It's needed to get feedback.
You guys should drop, lower that to
Yep.
50 to 100.
Mhm.
And run it, and then running it again, well, just kind of starts and stops.
Mhm. And yes, how to say, I do this way because my
Speaking of that, by the way, I don't know if you cared that much, but I remember you asked last time to figure out how to get yours to email you when we're done.
Yes.
Figured that out. And oh,
But you can tell by words and you figure it out.
yeah, I can just send the command. There's just a line or two you have to add.
So which key that it used like minus Q minus N minus T. So which you remember?
It was a couple of different ones, I think. One for when it starts, one for when it finishes.
Uh-huh.
So,
We'll figure it out
yeah,
later.
I'll just,
You can also try help or man erase everything. Man space a bunch. Please. Yes. And if you scroll through the just doing the questions with all the script can be something or just scroll through this parsing of the word.
anyway,
Yeah, it's so too much to.
I had it at one point.
Yeah, yeah.
What query I used to run that? Because, oh yeah, but I got one last question.
Yes, please.
That was. So